Good morning, Mr. Tortoise Higher Class, and welcome to the first of our online videos. I hope that you're all well and ready to engage with this online learning. So this week we're going to be looking at some further integration, but in order to make sure we're ready to see that new content, why don't we have a go at these 5 starter questions. Just pause the video at this point, because in a few seconds I'll reveal the answers. So it would be a good time, just pause the video, try these 5 questions, and then the answers will appear very soon. Okay, so here are the answers to the 5 starter questions. Hopefully you remembered that when we have in question number 1, where we have a function that's in the polynomial form, our kind of rule for integration is power up by 1 and divide by the new power. And then remember, each time we integrate, a constant of integration needs to appear. Question number 2 needed a bit of preparation first before you could integrate. And then question 3, we were looking at integrating trig functions. Again, use your notes jotter to remind you what does cos integrate to and what does sine integrate to. Question number 4 was using the chain rule. And then question number 5, a combination of a trig function with a chain rule step as well. So as I mentioned earlier, this week we're going to start looking at applications of integration, and the first thing we're going to do is look at differential equations, how we solve these and how we find a particular solution. So here is the note that it would be worth copying into your notes jotter. Again, just pause the video, get this note copied up, and then I will go and into a sort of a further live example that we'll do just after you get this note copied up. So copy the note up, try and follow along with what's going on. But as I say, if you need further instruction, there's another example coming up just in a few seconds. Okay, let's look at a further example here then. Again, pause the video if you need to, but we've got an example here where we're given the derived function f dash of x equals 10 root x plus 1. We are told that the point 9, 200 lies on the graph of f of x. So we're going to follow our success criteria on the left hand side here and get to a particular solution for f of x. So step number 1 says prepare f dash of x for integration. So we're going to take this function. It's not yet ready for integration. Don't like this square root sign. So we are just going to do our preparation for that, and we know our square root sign can just become x to the power of a half. So we're going to end up with 10 x to the power of a half plus 1. So that's me now at a point ready to integrate. So I'm going to go ahead and integrate this. So we end up with f dash of x being our integration steps. Remember, power is going to go up by 1 and we'll divide by that new power. So we get 10 x to the power of 3 halves divided by that new power of 3 halves. We know by now when I integrate 1, that's going to go to x. And then, because I've integrated, I always need my constant of integration appearing. Now just going to tidy this up. 10 divided by 3 over 2. Go off to the side and do that if you need to. But the quick method, let's multiply this denominator by the number at the top there, and we end up with 20 over 3 x to the power of 3 halves plus x plus c. So that's it now integrated. This is what we would call the general solution because we don't know what c is. So we want to go ahead and find c. To do that, this is when I use these initial conditions or a point on the line. So we're going to use this point here, 9, 200. Basically tells me that when x is when x is 9, then the y or the fx value has to be 200. So using that point, 9, 200, what we get then is I'm going to put 9 into my function. So I get 20 thirds of 9 to the power of 3 halves plus 9 plus c. I'm going to calculate this now. So basically I'm going to do the square root of 9 for 3, then I'm going to cube that for 27. I can divide that by the 3 here to give me 9 times by 20. The value of this first term here is 180 plus 9 plus c. And remember, we know that f of 9 gives me this answer here of 200. So I can just make this equal to 200. Okay, so 189 plus c needs to be equal to 200. Therefore, c needs to be 11. That's the only value that c can be. And then all I have to do for step number 4 is substitute that value of c in, and then I've got my particular solution. So up here, where I had my general solution, I'm now going to substitute the c with 11 down here, and then that's the particular solution. So I can say, therefore, f of x must be 20/3 of x to the power of 3/2 plus x plus 11. And that now is the particular solution. Okay, so hopefully you've been able to follow that through. If not, rewind the video, pause it, and just follow it through at your own pace. So hopefully this video and the examples that were in it have helped you to understand what's going on with differential equations. If you now feel ready to go into the textbook, then here is the textbook exercise I'd like you to have a go at. I've written down a selection of questions that I think are suitable. Again, don't spend hours and hours in this textbook exercise. Just make sure you've done enough to consolidate your learning and make sure you understand what's going on with the differential equations. If you're still not sure, then please, rewatch the video, have a look at the examples again. If you're still not sure what's going on, then either use the chat function in Teams to post any queries, or you can drop me an email and I'll try and provide further support on any questions that you're having trouble with. Remember, the solutions to the textbook can be found on the Madras Maths website. Always a very good idea to be checking your answers and make sure what you're doing is correct. Okay, so enjoy your differential equations work, folks, and keep checking back. I'll be posting up the new work for this week on a regular basis. So as I say, keep checking in, and please give me feedback. Let me know how you found the video, if there's any improvements that need to be made. Is there anything that's not working for you, or is there any more I can be doing to help your learning in this remote environment? Okay, thanks. See you later.